I hope I'm audible. Please just confirm with that thumbs up if you can hear me. Okay, thank you. Thank you. Thank you. Thank you. Okay, so good morning once again. My name is Shadrack Ndai from Pathways Technologies. I'm a data scientist. And today I want us to look at AI agents. So we are going to explore one of the most talked about topics in technology right now, which is AI agents. I understand this topic can sound very technical and intimidating, but I hope by the end of this session, you will leave with a clear understanding of what AI agents are, how they actually work, and most importantly, how they are already affecting our working, normal operations, and research and everything here in Kenya and across Africa. So before we dive in, let me quickly set the scene. You have probably heard phrases like ChatGPT, generative AI, machine learning. These terms are being thrown around everywhere, from newspapers like Daily Nation to boardrooms, let's say at the Kenya ICT Authority. But AI agents are something slightly different and significantly more powerful than the AI tools most people are already familiar with. So by the end of this session, we'll be able to explain the difference between an AI chatbot and an AI agent. You'll understand how agents think, how they act. You'll see some of the real Kenyan and African examples, and you will know exactly where to start if you want to begin exploring these tools yourself. So just a moment, let me just share my screen. I hope you can all see my screen. Okay, thank you. So let me walk you through what we'll cover in today's session so you know exactly where we are going. We'll start with the basics. What actually is an AI agent? Not the jargon definition, but a real plain English explanation that you could use to explain to anyone. So from there, we will go inside the machine. We'll look at the anatomy of an AI agent and the different parts that make it work. Then we will look at the different types of agents that exist. We can then look at a simple demo. We can have a simple demonstration of all these. So after the demo, we look at specifically what this means for, let's say, education and research. Then we will have a look at some of the challenges and the ethical questions because AI agents are not perfect, and we need to talk about the risks clearly. So we can look at then you can look at the key takeaways and then discuss some of the questions. Please feel free to type any question in the chat box. Sorry, in case you have anything to ask, just interrupt and you can raise your hand. You can unmute yourself. You can type in the chat box. Sorry, as we move on. So let's begin. So before we even look at what an AI agent is, we can first understand, we can first discuss what is artificial intelligence or what is AI. So AI it is a technology that simulates human intelligence by learning from data or recognizing patterns and making decisions or predictions. So artificial intelligence refers to computer systems that are designed to perform tasks that normally require human intelligence. These are tasks that people usually do using their brains, such as learning from experience, understanding language, recognizing image or faces, identifying patterns, and making decisions based on information. So it's important to clarify that AI does not think or understand the way we humans do. AI it doesn't have emotions or consciousness or common sense. Instead, it works by processing large amounts of data, identifying patterns in that data, and then using those patterns to make predictions or decisions. For example, imagine training an AI system using thousands of images of cats and dogs. Over time, the system learns the patterns that make a cat look like a cat and those patterns that make a dog look like a dog. Later, when shown a new image, the AI can predict whether that image is a cat or it's a dog. That's one simple example of how AI learns from data. Uh, another concept that we need to understand before we move on to AI agents, it's what we call generative AI. Now, generative AI is a special type of artificial intelligence or AI that can create new content. This is what makes it different from the many earlier AI systems. So the traditional AI is mainly designed to analyze information, find patterns, and make predictions or decisions. For example, a traditional AI systems can detect fraud in banking transactions, recommend products or videos, recognize faces in photos, or predict weather patterns. In all these cases, the system is mostly looking at the existing data and trying to classify, predict, or recommend something. So generative AI goes a step further. Instead of only analyzing data, it produces something new. It can write text, it can generate images, it can create music, or suggest ideas, or produce, let's say, computer code based on what it has learned from the large amounts of data that was used to train it. So the simplest way to explain the difference is this: like the traditional AI, it analyzes, while the generative AI, it creates. That is why generative AI has gained so much attention. It allows people to move from asking a machine to identify or predict something to asking it to actually produce content for them. And a simple use case is ChatGPT. So a simple analogy, you can think of a traditional AI as a judge. A judge looks at the available information and then makes a decision. In the same way, a traditional AI, it will look at data and decide what category something belongs to, what it's likely to happen, or what recommendations it's likely to make. So generative AI is more like an artist or a writer or a creator. It takes what it has learned and uses it to produce something new, whether that is a paragraph, an image, a song, idea, or a piece of code, whichever it is. So some of the well-known examples of generative AI tools today is the ChatGPT, which generates text. It can answer questions, explain topics, draft emails, summarize information, and all that. We also have others like the DAL, we have GitHub, Copilot, and so many more. So it's important to understand what these technologies are before we get to understand what AI agents are. So what is an AI agent? An AI, this is an AI that can perceive its environment, make decisions, and take actions to achieve a goal autonomously. Now, let me break that down using something we can all understand. Imagine let's say you are a lecturer and you need a research assistant. You have two options. The first option, it's you hire someone who sits at their desk and waits every time you walk in and tell them exactly what to do. For example, go and search a particular paper and bring it to me, and they do that. The moment you stop giving instructions, they stop working. That is your regular AI tool. For example, the ChatGPT. When you just ask it a question and it answers, it is reactive. So it waits for you. It waits for instructions. Each time you give it an instruction and it gives you results. The second option that you have, you can hire, let's say, a junior researcher, and you say, maybe you give them an instruction that I need a full literature review on mobile learning, let's say mobile money adoption in East Africa by Friday. So that's an instruction you're giving that assistant, and then you walk away. So that person goes, they go online, they find the papers, they read them, they synthesize the key themes, identify gaps, format it, and they format it the way maybe you want it, and places the completed document on your desk. So you gave them one instruction and they took all the steps independently. So that is an AI agent. The agent goes, it does not wait to be told every single step. It has a goal. It makes a plan, and it executes that plan on its own. So looking at this table on the slide, a regular AI waits for your question. An agent sets its own sub-goals. So if you say, help me plan next semester's curriculum, or let's say the instructions that you give to the AI. So a regular AI will give you a generic response. An AI agent will ask itself, what do I need to do first? Let me look at what this person has done before. Or if it's a lecturer, let me look at what this lecturer has taught before. Let me check what the current syllabus requires. Let me check what skills employers are asking for in the, let's say, Kenyan job market. Then let me draft the curriculum. It creates its own, it creates something like a to-do list. It comes up with a plan of the activities it needs to take in all that process. So a regular AI gives one answer, and an AI agent takes a sequence of actions. It might search the web, open a document, write some text, check that text, revise it again, all without you being involved. So a regular AI doesn't have memory between chats. An agent can maintain memory. So it remembers that, let's say last week you told it, let's say if you're a lecturer, it can remember that maybe last week you told it your students are mostly maybe second years engineering students. So it uses that context when helping you today. A regular AI has no tool use. That's another difference. A regular AI has no tool use, and these are big ones. An agent can actually do things. It can search, let's say it can search, let's say Google, write and run a computer program. It can read a PDF. It can send an email. It can fill a form. So it's not just talking, it is acting. And finally, you drive a regular AI while an AI agent drives itself. So this is very fundamental difference. And as we go through this session, everything we discuss will build on this core idea. Agents can act, they can plan, and they can remember. They don't just respond. Now that we understand what an AI agent is, let us go inside one and look at how it is actually built. There are four key components, and they all feed into a central brain. So the first component is its perception. Perception is how the agent takes an information from the world. A human perceives through their eyes. We humans perceive through our eyes and ears and nose, the senses. An agent perceives through data. It can read a web page, open a file, it's a PDF file, receive a message. It can also query a database or receive the output from the sources, like let's say an API. So in a simple context, imagine you have an agent that is built to monitor, let's say, news about the education sector in the country. Its perception is reading the news articles, the newspapers, uh, uh, every early in the morning. Then it sees the world through those inputs. The next thing is it's now the memory. And the memory has two types, which is very important. We have the short-term memory, which is like your working memory during a conversation. It is everything the agent knows right now in this particular session. When you are talking to a tool like, let's say, ChatGPT, and it remembers what you said 3 messages ago, that's now the short-term memory. It lasts only for that particular session. We have the second type, which is now the long-term memory, and this is like let's say filling a cabinet. The agent can store information in a database, and it can retrieve it for later use, even in a completely different session. This is what allows an agent to remember what you are or who you are. For instance, maybe you told it, maybe you are a lecturer or yeah, you're a lecturer, let's say working for Open University and specialize in renewable energy, and that let's say you give it more information about yourself. Let's say uh, uh, let's say you give it information. You're a lecturer in a certain university, let's say Open University, and you specialize in a specific topic, and that maybe last month you were working on a particular project. So it retrieves that knowledge to serve you better today. So it keeps that memory, that context you gave it initially. It keeps it and retains it for so that each and every time you interact with it, it remembers the identity of you and it gives you information based on who you are. Now, at the center of it all, it's now the LLM. This is now the brain of the agent. An LLM, it stands for a large language model. This is the intelligence engine. It is what you know, like as now for the chat GPT that we normally use, we have a model called, let's say, GPT-5. Now this is the latest model they use, or we have Cloud or Gemini. So the brain receives all the inputs from perception and memory, and it then decides, let's say, given everything I know, what is the best next action? Now that is the LLM reasoning. You feed it all the data, give it the prompt, what you want. So for it, it figures out on its own. Now that you given me all these tools, what is the best next action that I need to take? You can think of it as the part of the human brain responsible for decision making and reasoning. And the next part is now the planning. This is where the agent breaks a big goal into smaller steps. This is what separates an agent from a simple but the usual ones that we normally interact with. Let me give another example. Imagine you wake up maybe one Saturday morning and you tell an agent, you give it an instruction to plan a birthday party for my child this weekend. So the agent does not just say, okay. It first thinks, step one. So it will check the calendar for any conflicts on, let's say, Saturday and Sunday, because you want it to plan for a birthday party for that particular weekend. So it will check the calendar for any conflicts on Saturday or Sunday. Then step two, it will search for, let's say, party venues within, if it's Nairobi or whichever place that are available this weekend and suitable for specifically children. So the next step, it might look for, let's say, caterers nearby and check their reviews. Then it goes ahead to find, let's say, a birthday cake supplier that can deliver on a short notice. Then the next step, it can draft, let's say, a WhatsApp message to send to the parents of the invited children to that party with the venue details and time. After that, it can go on and set a reminder for, let's say, Friday evening or whatever date you want it to remind you or people. So it can set the reminder for that day to confirm bookings. Then after that, it can prepare a budget summary for all the costs. So it goes through a series of steps. It doesn't just respond to instructions. It thinks and plans and executes a particular action. So it creates an entire project plan from one instruction. So finally, we have the action and tools. This is Now this is where the agent actually does something in the real world. It can search, let's say Google, run a Python script. It can write to a spreadsheet. It can send an email. Uh, it can fill an online form. So actions are what makes uh, this is what makes these agents very powerful beyond just generating text. Now, if you notice these arrows in the bottom, they observe, think, act. This is what we call the agent loop. After every action, the agent observes the result, thinks about whether it worked, and then it decides the next action or the next course of action. It keeps looping until the goal is achieved. So this loop is this is now like it's like the heartbeat of every AI agent. They have to go they have to go through all those steps. Okay, sorry about that. So let's look at the types of an AI agent. Agents are they're not all the same. Over the years, the researchers in artificial intelligence have classified agents into different types based on how they think and how they make decisions. Let's look at these types. The first type is simple reflex agent. This is the most it's the most basic kind of an agent. It has no memory and it does not plan. It simply looks at the current situation and reacts on a fixed rule. A classic example is uh, let's say an email spam filter in our applications, in our phones. It sees an email, it checks, then checks, for example, does this email match the spam pattern? If yes, it moves that email to spam. If no, it then moves that email, let's say, to the inbox. That is it. Not thinking beyond that moment. So this is based on information that it has been trained. The AI is trained based on examples of, let's say, this email. If you see these patterns in an email, then classify this email as a spam. If these patterns are not available in that particular email, then this is a genuine email. So the agent just stops at that, doesn't do anything beyond that. The second type is a model-based agent. Now, for this agent, it keeps a mental model of the world. It tracks what it knows about its environment, even when it cannot directly see it. Think of it like a car's GPS navigation system. So the GPS it doesn't just react to what is in front of you. It has a model of the entire road network traffic. It also has access to conditions, estimated travel times. So it uses that model to plan let's say maybe you're going from Westlands to, let's say, JKA. So it helps you plan your route during rush hour and suggesting maybe the easiest route that doesn't have traffic and all that. The third type is now the goal-based agent. This is where it starts now to get interesting. The agent is given a goal. Then it's given a desired outcome. And it works backwards to figure out what steps it will get in order to reach that particular goal. You can think of, for example, the M-Pesa fraud detection system. The goal is to prevent, let's say, fraudulent transactions. So given every transaction, it asks, does approving this action bring me closer to, does it bring me closer to, or does it bring me further from a fraud-free system? So it makes a decision in service of that particular goal. The fourth type is now the utility-based agent. This agent, it does not just try to reach a goal. It tries to find the best possible way to reach that particular goal. It weighs the trade-offs, and a good example is, let's say, the university timetabling system that optimizes maybe for lecturer availability, student workload, room capacity, and minimizing clashes, all at the same time. So it finds the solution that maximizes overall satisfaction. The fifth type, it's a learning agent. Now, this is an agent that improves over time from experience. It tries something, gets feedback on how well it worked, and adjusts its behavior. So this is how recommendation systems work. The more you use, let's say, YouTube or the Safaricom M-Pesa app, and the more you use it, the more the system learns your patterns and improves its suggestions. We have an agent that's called the AlphaGo. That AI, that agent, it was able to beat one of the world's best player in a game called Go. So how did it achieve that? It was able to learn by playing millions of games against itself. So this agent was able to learn over time, and after a certain period of time, it was able to beat the best player in the world for that particular game. So this is just a perfect example of a learning agent, how it does. The sixth type, and this is now the most exciting one in the current research. It's a multi-agent system. This is where you have multiple agents working together, each with a different role or specialization. Think of it like maybe a well-run research department in an institution. So one agent specializes in searching for papers. Another one specializes in maybe reading and summarizing them. Then we have another agent that identifies the research gaps. Then another agent, it drafts maybe the literature review. So, and also you can have a fifth one that checks the citations. So they work as a team, passing work between themselves, and the final output is far better than any single agent could produce alone. So the most powerful AI systems being built today by companies like, let's say, Microsoft, Google, and OpenAI are multi-agent systems. And frameworks like, we have frameworks like the Creo AI and Autogen, which we'll see them in the future slides. They are built specifically to orchestrate these kind of agent teams. So the main takeaway here is that not all agents are created equal. the type of agent you need depends on the problem you are trying to solve, that particular problem you are trying to solve. So let's look at these. AI agents are not, they are not future concept. They exist right now, and people are using them every single day. Let's look at some of these examples. The first one is an agent called Devin, which was built by a company called Cognition AI. So this agent is the world's first AI software engineer. You give it a bug or an error report or a feature request. For example, let's say maybe you're a software developer or you're trying to come up with something, and there's a bug or an error in that particular system. So let's say you give it a prompt or an instruction that, let's say you're building a registration portal. So you instruct it that our student registration portal crashes when two students try to log in at the same time. So Devin goes, it will go and fix that particular bug. It reads the code base, it identifies the problem, then it tries the fix and runs tests to confirm the fix works. Then it submits the changes for human review. It does the entire job that a junior developer would do from start to end. So the second one is the Perplexity AI. This is a research tool. Instead of typing something into Google and getting a list of links that you then have to open and read one by one, this Perplexity AI, it actually reads those particular pages and gives you a synthesized answer with the citations. So instead of spending a lot of time doing research, you get a well-sourced and referenced answer in just seconds. So this is a research agent. The third one, it's now the Auto GPT and the Agent GPT. You give these tools a high-level goal. For example, research the 5 largest manufacturing companies in Kenya and write a 2-page competitive analysis. The agent breaks that into steps. It will go to search the web, it will read results, draft sections, and sample the final document. So you gave it one instruction, but it did multiple steps together. The fourth one is the Cloud Code, which is the tool that I personally use for coding work. You open your terminal, give it access to your project files, and you say, you give it an instruction. For example, after giving it access to your files, you give it an instruction that add a feature that sends a reminder email to students who have not submitted their assignments within 48 hours of the deadline, whichever instruction you give it. So it reads your entire code base. It plans all the changes it needs across the multiple files, and it makes those particular changes. It runs the tests and it tells you it tells you the exact steps it took and what it did. So it works like let's say having a senior developer sitting next to you. So the fifth one, it's the notebook LM. which is made by Google. And this one is specifically very relevant for researchers. You upload your PDFs, research papers, lecture notes, reports, and the tool, it's able to read those particular documents. You can then ask a question like, what are the key themes across these 10 papers? Or which authors disagree